Welcome to the DIY Honda Garage channel. The DTC P0793 indicates an issue with the intermediate shaft speed sensor A circuit, specifically a no-signal condition. This error arises primarily from electrical circuit malfunctions and not mechanical defects in the continuously variable transmission, CVT. The intermediate shaft speed sensor plays a critical role in monitoring the rotational speed of the transmission's intermediate shaft, which helps in the precise control of gear ratios. Typically situated near the CVT housing, it connects to the powertrain control module, PCM, via a wiring loom. Diagnosing this fault requires understanding both the sensor's function and potential electrical issues impacting its performance. When engaged, the false readings can disrupt the vehicle's transmission management system, causing suboptimal driving conditions. Therefore, appropriate troubleshooting measures must be implemented upon detecting this code. DTC P0793 is classified as intermediate shaft speed sensor A circuit no signal. This indicates that the sensor is not sending any signal back to the PCM, which affects how the vehicle functions, particularly regarding transmission performance. The intermediate shaft speed sensor is vital as it measures the rotational speed of the intermediate shaft, allowing the PCM to modify the transmission ratios accurately. This sensor is located within or near the continuously variable transmission, and any malfunction can lead to significant performance issues, such as erratic shifting or slippage. Understanding that this DTC stems from an electrical circuit issue rather than mechanical failures helps direct the troubleshooting efforts. If mechanical problems are suspected, they must be ruled out before proceeding with electrical diagnostics. Several potential causes can lead to the activation of DTC P0793. An open circuit in the VCC1 wire can prevent the intermediate shaft speed sensor from receiving proper voltage, leading to a no-signal error. Similarly, if there is a short to ground in the NDR-DD wire, the sensor may malfunction, directly impacting its ability to communicate with the PCM. A faulty speed sensor itself can also be responsible, resulting in incorrect readings or complete signal loss. Additionally, poor electrical connections, such as loose terminals, can interfere with the circuit's integrity, leading to intermittent symptoms. Therefore, a thorough investigation of both the wiring and connectors is essential for accurate diagnosis and repair. Identifying symptoms associated with DTC P0793 helps in prioritizing your diagnostic steps. Drivers may notice erratic shifting, where the transmission fails to engage or disengage smoothly, leading to discomfort during driving. Transmission slipping can occur, where the vehicle struggles to maintain power as the gear ratios may not adjust correctly, making acceleration difficult. Additionally, the check engine light or other warning indicators may illuminate on the dashboard, alerting the driver to an underlying issue. These symptoms not only compromise driving safety, but can also lead to more costly repairs if not fixed in time. Observing these signs should prompt immediate vehicle inspection to prevent further damage or performance impairment. In the first troubleshooting step for DTC P0793, it's crucial to verify the reported problem accurately. Begin by turning the vehicle's ignition to the on position. This helps power the diagnostic equipment. Next, use the Honda Diagnostic System, HDS, to clear any existing DTCs, including P0793, from the system for a clean slate during testing. After clearing, raise the vehicle and ensure it is securely supported, allowing the front wheels to rotate freely as you start the engine. Enter the Vehicle Stability Assist, VSA, maintenance mode in the HDS, which is necessary for certain diagnostic functions. Then, drive the vehicle in D position at speeds exceeding 19 miles per hour for at least 30 seconds to reproduce the fault conditions. Finally, recheck with the HDS for any pending or confirmed DTCs to determine if P0793 is indicated again. The second step focuses on pinpointing the failure area related to DTC P0793. Begin by turning the vehicle ignition to the off position. This is essential for safety reasons while working with electrical components. Then, proceed to disconnect the CVT drive pulley speed sensor's 3P connector. It's crucial to ensure safe handling to avoid damaging the connector or wiring. After disconnecting, turn the ignition back to the on position and measure the voltage across the specified test points. You will take readings between test point 1, female terminal number 1 of the CVT drive pulley speed sensor connector, and test point 2, which refers to body ground. Your goal here is to check for a voltage reading nearing 5 volts. If this condition is met, the troubleshooting continues. If not, move on to isolate further issues like loose connections or a defective wire. For the third troubleshooting step concerning DTC P0793, focus on checking the VCC1 wire for integrity. With the vehicle in the on mode and the CVT drive pulley speed sensor 3P connector still disconnected, measure the voltage between test points 1 and 2 again. In this case, test point 1 is female terminal number 3 of the CVT drive pulley speed sensor connector, while test point 2 remains body ground. The expectation here is to find a reading that is about 5 volts. If the measurement confirms the voltage, it indicates that the signal is getting to this point, and you can proceed to check the next connections. However, if the voltage is absent, it indicates an open circuit in the VCC1 wire, necessitating repairs to ensure proper connections from the CVT drive pulley speed sensor to the PCM. The fourth troubleshooting step involves checking the functionality of the CVT drive pulley speed sensor itself. Again, ensure that the vehicle is in the on mode while leaving the CVT drive pulley speed sensor 3P connector disconnected. Measure the voltage between test points 1 and 2. Test point 1 should connect to female terminal number 2 of the CVT drive pulley speed sensor connector, and test point 2 should correspond to female terminal number 2, free of the same connector. The goal here is to ensure there is a reading of approximately 5 volts. If this is confirmed, the next logical step is to replace the engine speed sensor to resolve the DTC P0793 error completely. Conversely, if the reading is not as expected, corrective action should include repairing an open circuit in the SG1 wire linking the CVT drive pulley speed sensor to the PCM. The fifth step in troubleshooting DTC P0793 involves investigating potential short circuits in the NDR-DD wire. Start by turning the ignition to the off position for safety and to avoid any potential electrical hazards. It's crucial to jump the SCS line with the HDS, a step necessary to protect the powertrain control module, PCM, from damage during testing. After this, disconnect the PCM connector C, which has 51 pins. Following that, check for continuity between test points 1 and 2 while keeping the CVT drive pulley speed sensor 3P connector and PCM connector C disconnected. You will be verifying the continuity between the sensor's female terminals and body ground. If continuity is found, this indicates a short to body ground within the NDR-DD wire, necessitating repair. If no continuity is found, the NDR-DD wire is not shorted, and you can safely proceed to the next step. In the final troubleshooting step for DTC P0793, focus on performing a continuity check of the NDR-DD wire. With the vehicle in the off mode and the CVT drive pulley speed sensor 3P connector still disconnected, and also the PCM connector C 51 pins disconnected. Measure for continuity between test points 1 and 2 again. The goal is to check the connection between female terminals of the CVT drive pulley speed sensor and the number 33 pin of the PCM connector. Achieving continuity confirms that the NDR-DD wire is functioning correctly. If this test is successful, checking for any authorized service bulletins or further information related to DTCs is prudent. Should the continuity check fail, it indicates an open wire situation that needs repair to ensure proper communication between the sensor and the PCM. After addressing the issues causing DTC P0793, it's vital to perform a final repair verification to confirm that the errors have been resolved. Begin by using the Auto Diagnostics system, HDS, to clear any stored DTCs. Following this, take the vehicle out for a test drive, ensuring to replicate conditions that previously produced the error. Drive the vehicle and monitor its performance for any signs of erratic shifting or slipping. Conditions previously associated with the transmission issue. After the test drive, immediately check the HDS once more for any confirmed or pending DTCs. If P0793 remains absent, this verifies that repairs were successful and the system is functioning optimally. Preventive maintenance plays a critical role in avoiding future occurrences of DTC P0793. A key aspect is to perform regular electrical inspections, which can include checking wiring conditions, connectors, and terminals associated with the intermediate shaft speed sensor and the transmission system. Monitoring for corrosion, wear, or damage ensures robust electrical communication, crucial for sensor performance. Additionally, servicing the transmission according to the manufacturer's schedule can help maintain its health and longevity. By keeping all connections clean and ensuring that no wires are disturbed, the likelihood of encountering similar DTCs can significantly decrease. Regularly educating vehicle owners on signs of transmission issues also fosters early detection and timely repairs. In summary, addressing DTC P0793 requires a clear understanding of the intermediate shaft speed sensor's role within the vehicle's transmission system. Following the specifically outlined diagnostic and troubleshooting steps is essential for resolving the issue effectively. Recognizing that this code points to an electrical problem rather than a mechanical failure simplifies the approach. Ensuring that all electrical connections are intact and operational can lower the risk of similar codes in the future. By engaging in preventive maintenance and taking corrective actions as needed, vehicle owners can ensure long-term health and optimal performance of their Honda CRV. By remaining vigilant, many issues can be prevented before escalation, securing a more reliable driving experience. Please like and subscribe to the channel. See you next time.